Here's load average. Load average is a measure of how many processes are running at any particular time on the database. The load average will normally be less than the number of cores that you've got in the server if things are happy. Once it starts climbing above that number, you start getting contention between cores, things kind of fall apart. So this is an operating system number that you can get by pulling times, but graphing it over time. It's kind of like a gross figure for what's going on with CPUs. This is a low-level detail from Munin. Munin actually displays this information in a somewhat unique format that I found I really like. So the concept here is there's 8 processors on the server, 8 cores, and this total goes to 800%, because essentially if every processor was 100% utilized, that would be 800% total. And it breaks that down by what those things are doing. So the main categories here are all of this yellowish stuff that's in here. That's idles. This is when the server is doing that. This blue stuff here, this is when it's actually running stuff in user land, which is typically the database queries are running. This green stuff you can just barely make out at the bottom. That's the operating system doing things. If you've got some sort of slowdowns because the operating system is doing wacky things with sockets or other networking stuff or whatnot, one of the ways you can tell that is that system number starts becoming a disproportionate amount of the total relative to the rest of it. And then this purplish bit at the top, that's I/O wait. That's how often one of the processes on the server was waiting for disk activity to happen. So this example right here, we can see 2 distinct type of workloads, or 3 distinct really. We've got most of the time where the server's doing nothing. Then we've got this here, which this is, if you notice, this is exactly at 100%. This was running something that was running one giant query that kept the CPU busy all of the time, but did no disk activity. That's what it'll look like. So that's running like that. It's not touching the disks. It's not using all that much resources, but one of the queries is stopped just using the entirety of the CPU. This is a little bit different than this time period here. Here we can see that there's a CPU that's trying to run at 100% of the time, but it's not really working because there's a good chunk of time where it's waiting for I/O during that whole section instead. So this was actually a section of time where I was loading data in a way that there were 2 processes involved in the whole thing, and then so at any particular time, one of them was actually doing the work, one of them was doing importing related stuff, and then, well, why do these numbers add up? They're more than 100%. The third thing that was involved in this whole mess was Postgres' background writer, which was also busy doing waiting for a lot of the I/O and doing other stuff. So if you display this information with other monitoring tools like Hackney and whatnot, the graph isn't quite as slick as this one, but the same basic data is there. You really need to sort out CPU time versus system time versus I/O wait time, and then idle time is whatever's left over the whole thing. Keep track of that stuff. It's important. And then even on Windows, the same set of counters are there. They're named slightly differently. I even put a little court translation table in my book to make it easier to figure out what they're called. But the way that you monitor a server and CPU resources versus anything else are the database and any operating system. This is disk utilization percentage. The idea is that Linux gives a number between 0 and 100 for what percent of the time approximately it was waiting for the disk at any particular moment. So what you want to watch for here, and this is the same section of time we were just looking at, so this is where I start talking about lining things up. You notice 11, 12, 14, 15, these are days of the week. And so we've got this ugly section here, there's a lot of waiting for I/O. We now drill down into what exactly was going on. Now we can see exactly what was going on. For whatever reason, this green bar here, this represents SDA, so that's the first of 6 disks that have to be in the system. So whatever was going on the server, it was doing a little bit of I/O to the other disks, but the process was hitting some sort of bottleneck where that SDA disk was busy 100% of the time. When you see a particular disk is sitting at 100% utilization and I/O weight is high and everything else, that's probably where your bottleneck is whatever's going on in that disk. In this case, the particular bottleneck happened because SDA happened to be where the data files I was loading was at. The things down here in the CD, E, and F, those are actually the database disks itself. And so the bottleneck was basically it couldn't, the loading process I was going through couldn't read, it was reading inefficiently, it was bad script. And it was actually using the whole disk up for what it was doing and not actually keeping the database busy at all. So if I would have had this kind of per disk breakdown, I might have thought the database was the bottleneck, but it wasn't. It was totally sitting over on the operating system disk, which happened to be where I put all the data files on. This is why breaking this stuff down per disk and converting it to a percentage is useful. This is the same data you get out of, I mentioned IOStat-MX before is a good command. That also spits you out a this percentage. Connections. This we talked about it already too. Connections in Postgres, they can be active, which means they're running the query right now. The active ones are those green ones down at the bottom. The orangish ones that are the majority of those are idle connections. So someone is connected to the database, but at that particular moment in time, they're not actually running a query. The connection's open and the server's sort of waiting for them to request the next chunk of data. This information is extracted from PGStat activity. This is essentially PGStat activity grouped by whatever the transaction state of the thing is based upon what command it shows. It just so happens that in Postgres, something that's active but idle has the text greater than less than brackets idle in it. And so if you specifically look for those and you look for ones that say idle and transaction and whatnot, you can derive this data. So this is a good example of what I was talking about where using view, and I really like the way that this was displayed in Union. I think it's a good way to look at it, this kind of stacked chart thing. And I had a customer that we were trying to figure out how to set work memo on the server. We needed to know how many active connections were there, as opposed to ones that were just sitting idle. And this is how we wanted to extract that data. Well, the problem is they weren't running Union. Well, we went and looked at the source code of Union, found this query that actually extracts this data from PGStat activity, and then figured out how to get the same data to show up in Happy instead. So there's no reason you could pull this data out as a regular old query. It's just some relatively slick SQL that someone put together that summarizes the data in a useful way, and you don't have to be using this monitoring system to get it. You're using another one. You can take this concept and do your own implementation of it by monitoring PGStat activity. So when we were talking about things like workmen before, and the question were, well, do I size it based on the total connections and active connections? This is a way you can figure out how many are the actual active connections, to fine-tune that a little bit better. While this system has over 300 people connected to it at any point, it's pretty obviously not ever running 200 concurrent connections at once. So you might be able to set workmen a little bit higher on this than you would just by assuming every connection is active. This gives you an idea of the kind of data you can get out of the shared buffer statistics. This is showing what everybody's reading out of shared buffers and how often it's hit. Those graphs are often the same, suggesting this data is mostly cached. The sort of stuff you want to look for on this are, like this isn't so strange. This big green bar says, this is from the, that is one of the data to look for. That's saying that a lot of data actually had to get read from the operating system during that particular chunk of time. So, that represented something that was doing a bad operation in the database. So when I see something like that, I go, wait a minute, are the sort of things that sometimes need to do. This is the summary